Hello, I am Brock Stanton. I am an aspiring meteorologist, and today we are going to be talking about this day 2 and day 3 risk. And these days each have potential and I would say likelihoods to be tornado outbreaks. But there's also this day 1 risk, which trended up a lot since yesterday and was a lot more than what I was expecting, but we can see there's a 10% risk for strong tornadoes, so we could see perhaps a localized tornado outbreak. But the main story is going to be this day 2 and day 3 risk. I think the greatest potential for tornadoes is going to be in like north central Iowa here. We'll discuss that later, but really the parameters for tornadoes are very favorable all along the dry line here, but storm coverage is going to be very isolated, so it's just there's not enough storm coverage to warrant a higher categorical outlook. And then for day 3, there's a lot of uncertainty, but a widespread severe weather outbreak does appear likely. We'll get more into it later. Let's take a look at our 18ZHRRR. We're going to take a look at it for the area in Iowa. And we're going to move into the day, and we can see how we get into the evening hours. We get these semi-discrete supercells. These like embedded to semi-discrete supercells developing. And the shear environment, I will show it to you in a minute, is extremely favorable for strong tornadoes. So, and then here, look, in this area here, the storm tries to become more discrete. Again, this is just one model run. And you can see looping hodograph, favorable for strong tornadoes. Moderate cape, there's that capping inversion, but the forcing is a lot stronger up in this area, so that capping inversion will be overcome. And yeah, everything about the sounding really screams tornado potential, but there's some uncertainties with it. Still, the storm mode is very questionable. Some models don't even fire it. Don't fire this mode except for this line of storms back here. Some models just don't fire this line of storms, which, by the way, I forgot to mention this in the intro. There is a 30% wind related with this, and then all the way down the dry line here. I'll take a quick look at it. There's still at significant hail risk. That's what's driving most of this enhanced risk now compared to the tornado potential. But again, this localized area in Iowa, especially I think up here, has a localized significant risk for tornadoes. So that's what the HRRR tries to do with the reflectivity. Let's just play it out some. Okay, now we're going to take a look at the 850 jet. This is very important for calculating our tornado potential. And you can see how by 0Z we have a 40 to 50 knot low level jet, and it just explodes. So any semi-discrete storm in this environment would be capable of a strong long track tornado. And I really think even like along the line of storms or an embedded supercell, the low-level shear is going to be so strong that I do think we can still see strong tornado embedded within the line. But again, I think north central Iowa is probably going to have the greatest chance because there is that risk of semi-discrete supercells firing ahead of the line. Let's take a look at our storm relative helicity values, and we're going to see how into the evenings at 7 o'clock central time they just explode. And let's say by 1Z, widespread values over 400, and a little farther south you still have values that are more than sufficient for strong tornadoes. You look for values over 200, we got values over 200, 250, and still over 300 here, so it's not like, even if you're not in the area that gets a supercell in Iowa, I think you're still going to have a risk for strong tornadoes, because can we get into the overnight hours where there's still sufficient cape, and now these values of over 400 spread all the way south on the HRRR, so that's a potential for, well, maybe not the greatest coverage in area. Again, there's still that potential farther south, but for Iowa, maybe a fairly localized area of it coming together, but there's a potential for even within the line of storms of strong tornadoes, and then perhaps even some stronger long track tornadoes. if we can get that like a semi-discrete supercell to form. Now we're just going to show our 0 to 3 values quickly. Again, ridiculously favorable for strong tornadoes. Just ridiculously favorable for strong tornadoes. And our bulk shear, it's also going to be there. Like 50, in this northern mode here, like 50 to 70 knots. It's a little more farther southwest still, sufficient shear. Does tend to weaken a little bit as we get later into the overnight hours, and that's probably partially why that QLCS eventually weakens as we saw, but really this area in here has a decent potential for a tornado outbreak. Probably a little higher than decent, like a likelihood of a tornado outbreak in my opinion. And again, we're going to take a look at our blend of cape and shear, and we're just going to see how they really just develop into these overnight hours. Look at this axis here, and this is where we think storms will be. Down here we're not as certain, but in this environment here there will be storms, and they'll be capable of all hazards as a result of the very strong shear and at least moderate instability. We'll take a look at that instability now, and we are going to see that, again, this is our warm front right here. Right along it we're going to have values of like 1,000 to 2,000. Further south, where the shear is still very good, but not as extreme. And again, maybe a little bit later it does get more extreme down here, but it's more linear mode. Still very strong cape values. So all hazards seem likely with this mode in Iowa. Can see our significant tornado parameter just explode, and it kind of signifies how the environment is really favorable for strong tornadoes across Iowa. But however, I did mention how this risk does still have some uncertainty. Let's take a look at the NAM3K. And this model is a lot less bullish with this. It does not fire the renegade storms whatsoever. And look, the storms that it was showing over here, now they're over here at that same time. So it's a really complicated forecast. Let's just check and see what our 850 jet is like here. And it's slower with the system and still has this strong shear overspreading it. So it's a really complicated forecast with the system. You can still see we're going to have sufficient cape. Our storm relative helicity values are going to be there. Again, the placement of it is different on the NAM3K. I do believe if we check some other models, we'll see there's more support towards the area in Iowa compared to more of an eastern Kansas setup. Let's check this to confirm. And let's see what this model shows. And yeah, you can see how it has more of that severe weather event in Iowa. Again, maybe not as many discrete cells or in the exact same location as the ARRR. Maybe it's down here compared to more up here. But overall, Iowa event, the shear will be very good. Yeah, very strong shear on this. And we're just going to check this model as well. And just kind of see where it shows the placement for these events. And this one has it a bit farther west, maybe extreme eastern Kansas into western Iowa. So there's a little bit of uncertainty on where exactly the triple point. And again, that's the triple point is where the warm front, cold front, and low pressure system kind of all meet, and that's going to be where probably the greatest chance for supercell storms will be. So we're not exactly sure where that's going to set up, but wherever it does, there will be a heightened risk of strong tornadoes. We're just going to go take a look at our surface-based cape and photograph overlap to show this potential for strong tornadoes quickly. Again, for tornadoes, you want to see a looping photograph, and we're going to see all these photographs are going to be looping. Let's see the turning in the photographs. that supports our strong tornado potential. We are going to take a peek farther south. It's going to be a quicker look just because the confidence in storm coverage is significantly lower. But here it is. Again, this model just doesn't fire the storms further south. However, let's just check a sounding here and see what it does show. That model, okay, that one has a pretty solid cap in place. Let's go a little earlier and see what it shows around daytime heating. Shows much less of a cap there, so there though, the moisture there is not great. I think that might have been like, part of that sounding may have been on the dry line. Yeah, okay, that makes a little more sense. Dew points in the 60s, and then totograph's not great because the best low-level shear hasn't arrived yet, but the capping inversion is much weaker, so if that were to erode just a little bit more, we could see the potential for supercell storms to fire capable of all hazards. And we're just going to look, and we're going to see how this robust cape axis does develop and the low-level shear environment will develop. It's not going to be as strong as it is in the Iowa mode, but it's still going to be there be sufficient for tornadoes and perhaps some strong tornadoes if storms initiate. But again, convective initiation is just so uncertain that it's impossible to really know for sure until it actually happens. Not really a better way to put it. This southern mode, it's kind of like, it's like a forecaster's nightmare because the environment's favorable for strong tornadoes if a storm develops, but we just don't know if a storm's going to develop, and we may not know until the storm's developing or they're trying to develop and they just fizzle out. Again, quick look at our NAM. Very similar story. It doesn't fire any storms, but there is some potential. If we take a sounding, there's still a capping inversion there. Just take a sounding maybe in Kansas. We look somewhere along the dry on that one. Storm's not firing in that sounding. Let's just take a look at our surface-based capping inversion, just a broader look. And we'll see how it weakens throughout the day and how there could be a chance for storms to fire along this dry line here. See? Starts to erode a little bit there. This area in here where it erodes, there could be a chance for a storm to fire. Again, our dry line's probably going to be right about there. Let's check that. Yeah, so again, this quarter like up in here, maybe you could see a supercell storm try and fire, but it's very uncertain with the type of risk with this coverage of storms here. So the risk is just extremely uncertain for this mode. But with that, we're gonna move into the day 3 now, and we're gonna stay on the NAM 3K, but we're gonna have to shift over to the Ohio Valley. In this risk right here, it's just, there's so many complicated things that are going into this forecast for Wednesdays, and a lot of the ingredients seem to be coming together for a severe weather outbreak, but there's some very small scale things that could either limit this event or really not get in the way of it, and so that those type of things are going to have to be determined. You can see how these showers and storms move in overnight, and this could act to limit how much instability can develop and leave the atmosphere a little messy. But here, by 7, 8 in the morning, they start to clear out for the most part. And then you can see how this line of storms tries to organize. This is actually ahead of the main line. And on this run, it kind of struggles to get together. Seems to be there's still a lingering capping inversion on that. That could be the reason why. But then as we move in later into the afternoon, you can see how it starts to develop with here across southeastern Missouri, perhaps areas farther north. And then we perhaps get the southern mode down in Mississippi, a more moderate cape, stronger low-level shear, but doesn't quite have as much bulk shear for that event right now. Event down in Mississippi. But then we get into the evening hours, like dinner time, and storms just explode along the cold front. And here you can see these little hooks. We can see that's like embedded supercells within the line. Here we're going to actually try and zoom in so you can see it maybe even easier. Let's take a look at Arkansas. And we can see how they just, here, hooking there, down there, just all these storms hooking. And that's because there's a very strongly sheared environment for these storms and likely moderate instability. You can see all these little hooks in there. That signifies embedded supercells within the line. So that's a very dangerous look. Let's go back out a little bit and just continue to play this through. And I do think this round ahead of the main line, if it plays out like this, maybe it could inhibit instability a little more than what this model shows. But it also could either just not develop or maybe be more supercellular in nature. There's just so much uncertainty with this event, but at least at a larger scale, it seems like the environment is coming together for a severe weather and tornado outbreak. So again, we'll just have to see if we can figure it out by tomorrow where we think that greatest area will develop. But the NAM develops this large line of storms that's going to move eastward, and eventually it's going to weaken some into the overnight hours, but that would carry a significant damaging wind and tornado risk. And despite the storm mode being more linear on the NAM run, which the NAM does have a bias to be linear. Now, I don't doubt a linear mode for this right along the cold front, but this initial mode here, I'm wondering if we could see some more supercell development in this area, like basically out in the open warm sector ahead of that line, is what I wonder if we could see that happening some. But let's take a look at our 850 jet now, our low-level shear. You can see in the morning, and again, if storms could still be ongoing in the morning hours, perhaps have a chance to be severe because the shear is going to be very strong. But let's focus more into that afternoon and evening event. Again, we can see how this round out ahead of the showers and storms, if it gets going, would definitely have very sufficient low-level shear to produce tornadoes, especially with more supercellular storm mode, if that were to develop. But if we look, you can see our front here, and our low-level shear is going to be 50 to 65 knots, like 55 to 65 knots up in this area. Farther south, it's a little weaker, but maybe with slightly less forcing, we could get a more supercellular storm mode and combine. And like a 40 to 50 knot low-level jet is not weak by any means. It's just not like as extreme. It's just strong to very strong, not like extreme, like 55 to 65 knots. So our low-level shear is going to be there for damaging winds and tornadoes. And let's check out our tornado potential and see what it looks like on the NAM 3K. And we're going to see we get into the afternoon hours again. Any storm that could develop in the open warm sector would seem capable of all hazards. And then along the cold front here, we can see that these values are favorable for tornadoes. You want to see over 150 for tornadoes? Definitely have that. And especially in this northern area, we have values over 200. But then, as we get into the evening hours more, the low-level jet starts to re-strengthen. We're going to see these values become widespread over 200 again. And that does support that risk for strong tornadoes, even embedded within the line again. And our 0 to 3 level values are also going to be very favorable. You can see values of over 250, over 300 perhaps. Again, going to support that all hazard risk. So our shear is going to be favorable. Let's take a look at the Cape. And we're going to see in the day on Wednesday, you can see how the showers and storms move through because there's this gap in the instability axis. And that's one of the complicated things in the forecast is how long does it take for the atmosphere to recover from that. And we can see in the afternoon hours, and this might not be why it develops that afternoon mode ahead of the cold front, is that the instability, it's just not there. But then, as we get a little later into the day, the atmosphere is able to recover more, and we can see moderate instability develop. Combine that with a strongly sheared environment, and you're going to get storms capable of all hazards regardless of storm mode. So strong damaging winds, especially with any line segment with areas of moderate instability, you could see wind gusts of 74 miles per hour or greater, and widespread over severe force, which is 58 miles per hour or greater. Again, and then tornadoes, perhaps strong tornadoes regardless of storm mode, but the greatest tornado threat would be with that, if that afternoon mode does evolve, and then that afternoon mode would be capable, if that afternoon supercell mode does evolve, which I do think has potential to happen despite what models are saying right now, I do think that would have the greatest risk of strong tornadoes. But again, the winds are going to be so strong in the low levels that regardless of mode, we could see strong tornadoes. And one of those reasons I think we could see more supercell development ahead of the line are these lapse rates. We're going to see that into the afternoon hours. Look, in the afternoon hours, this is 4 o'clock Central Time, 5 o'clock Eastern, afternoon evening hours. I look for supercell development, I look for values over 7. Now, just because there's values over 7, that does not mean you're going to see a supercell storm mode. But there's going to be weaker convergence ahead of the cold front. Combine that with these lapse rates, and that does lead to make me think we could see more tornado potential ahead of the line than what the NAM shows. I also realized I forgot to look at the bulk shear, and this could end up being why there's not as much supercell development in the open warm sector. So it does start to come into the afternoon hours. Actually, comes in quite a bit, so just check a sounding here out in eastern Arkansas just for the sake of it. Curving hodograph, relatively weak cap if there's even any, basically no cap, so that tends to make me believe that if a storm does develop ahead of the cold front, which I do think is possible, all hazards possible. Again, that kind of supports that NAM is showing these shear values spreading out in front. We're going to take a brief look at the HRR. I only have like a minute or two left until I have to eat, so we're going to make this quick, but let's just take a look and see that this is the event that's ongoing right now. These supercell storms could develop, and if they developed as such, tornadoes, perhaps a significant one or two, would be possible. You can see there's our morning rain that could mess up with the event, and then here's our cold front here, and it develops these storms, and it can only take us through 18Z. So while it doesn't look as significant, the storms haven't really fired yet farther south, and it very well may want to do that in the 0Z run that comes out later this evening. However, the storm motion is faster, and that's something else worth noted, that the cold front's advancing quicker, so perhaps instability won't have as much time to develop. Perhaps the bulk shear may not overspread the warm sector as much. HRR is not liking to do that as much as of right now. We'll see if that were to change by when I cover it in the video tomorrow. Just gonna look at the blend of shear and cape quick, and keep in mind this only goes through like the early to mid afternoon hours, so we can't see the whole thing on this model, but that's kind of, we're seeing the HRR isn't quite as aggressive yet, but we'll just have to see. I will keep you updated. I will again be updating you on this risk tomorrow, because it's going to be, I think it's going to be quite significant. It's just a question of how much and where. Again, I do think we could see a moderate risk if mesoscale details become more clear for severe weather, but again, we're just going to have to wait, watch, and see. But I hope you enjoyed the video. Please consider liking and subscribing, and I will see you next time. Bye.